This
how
conference will now be recorded.
the classes are going to proceed. Okay, so as you all know, it's a virtual class, so I will have to share my screen and you will listen to my voice obviously. So generally what windows I use, okay, and what is my workflow, so let me explain that to you so you understand. Okay, so generally everything happens mostly over the browser or command line terminal where I have to execute commands. Okay, um, so I use Chrome to connect to GoToMeeting, and I use Firefox to kind of access the Amazon Web Services website or any other website like GitHub or anything else as well. And I use this thing called as draw.io, which is good for, I mean, drawing diagrams and show you, you know, things visually. Then if there is anything that I need to specifically make you understand, or I think writing down makes it better impact, I write down on a notepad. Here I'm using my Sublime. Um, yeah, and whenever we are writing long code, let's say a YAML playbook or a Terraform code, I use Visual Studio Code. Okay, you could also download it. It's a good tool, right? So we generally, so something like this. Okay, we generally have to interact with virtual machines created on Amazon Web Services on AWS. So for that, I open my terminal and connect through the terminal to that. But sometimes I open more than one window and toggle between different videos. I generally keep on saying that I'm changing window, but just keep that in mind. So yeah, basically these 4 or 5 applications are what I use um, to navigate across various things, right? So, and again, like I told you in the demo yesterday, if you have a question, you can pause. I mean, you can interrupt me and ask me, but maybe not in the middle of my sentence. Just when I complete the sentence and planning to go to the next, you can, interrupt me and ask a question. That's fine. Otherwise, most of the times, it's. I would appreciate if you all are on mute, so that there's no disturbance for others. Yeah, this class for the first week is going to be from 6 to 7, 6 a.m. to 7 a.m. Then it's going to be 7 a.m. to 8, um, or maybe 6:30 to 8, not yet decided, but something like that.
Hey,
Um,
Kiran,
okay,
I have a quick question about that.
yeah, go on.
I'm from Chicago, United States,
Hmm.
and this is actually time for breaking fast for iftar, and I'm fasting. Is it possible if we could? Well, it's just a question. I don't know if majority people are okay with it or not. But if it's possible, can we delay class for at least hour for this week? Like start at 8:30 Central Time, if it's possible, of
I know.
course.
Yeah, I know, because it's not about the participants. It's more of my thing because I have another commitment. I
Ah,
have another
okay.
7 a.m. IST. So
Okay.
yeah, sorry. Yeah, maybe for this week. Next week onwards, it's going to be 7 a.m.
Yeah, next week it's not going to be a problem for me anyways. Ramadan ends on
I
Monday, so
Yeah, I understand. I
yeah.
understand that, but unfortunately,
Okay,
I
that's
can't.
fine. Yeah, I was just
Yeah,
curious if it was
yeah,
possible. But okay, thank you though.
yeah. All right. Um, so yeah, that would be basically my workflow. But I may miss any of the questions if you ask in chat window while I was presenting something else. Okay. So that, keep that in mind. Maybe I'll take a look at the question later, but may not be able to answer immediately. Uh, Otherwise, yeah. So that's the workflow. Again, if you have any questions or if you have anything to do with my flow, you can stop me. And moreover, I go in a very free flow manner. It's not like I want to cover a topic in this day, so I do it anyway. No, I just like to explain things to you in a detailed manner. And so we could, I mean, for me, Driving the concept across is very important than, let's say, just saying that I completed this topic. Okay. Um, so hopefully you'll all will have a good time learning here. All right, let's get started. So before we,
Hey,
yeah,
sorry, Kiran. This is Akhil. So before
yeah,
starting up, I don't want, I'm sorry to interrupt, but as because most of us here from non-computer background too. So is it any way no, probably in next coming session or something, would you could, if you could share a little what you call the terms term there are all what you call the computer terms we are not aware of. So if you could make a note of those things, we might check from the Google. I mean Google, and we'll get back with the term because it's hard to understand few terms which we never heard of because
yeah. See, I
like
don't have any glossary.
objects, classes, everything. Yeah, exactly. Because directly we are getting high level stuffs. It's really hard to get through. Or suddenly it's hard to understand from either side. So that's the reason. If it's possible, if you could share some terminology of
Yeah,
some
see,
terms like very common terms which we can come across.
I don't have a glossary or list of contents like that, but I I explain every concept in detail. Yesterday, I know you, if you were part of the demo, you might have heard a lot of terms, uh, but that doesn't necessarily mean these concepts will not be explained. I'll explain everything in detail. If you require, definitely, I mean, I would say you yourself can initiate and make a list of it. Right now, I honestly do not have the bandwidth. If someone of you can take the lead and create a document, nothing like it. Okay. But yeah, as I said, whenever we discuss a topic, whenever a new terminology comes in, I mean, a new term comes into discussion, I will talk in detail about it.
Okay, good. Okay.
Kiran, I have one more question.
Mhm.
Uh, do you share recordings every day, like right after class?
I don't think it would be possible to share right after the class. Uh, maybe. Uh, Maybe by, let's say, midday India time. So maybe the next day morning you should have by your time.
Sure.
Yeah. Maybe a few hours after the class. That's what I could say. All right. So let's get started. Again, don't worry if there is any term that you don't understand. Feel free to ask and make a note of it. Google it and study all that. Okay. All right. So let's, before we start about AWS or any other thing, I would like to, explain a few concepts that might be beneficial to you. That are very required, in fact. Okay. Mm. So let's take a general scenario. Okay. Let's say you open a browser window and type in a website called as google.com. So what happens when you type in google.com? How does the page come to your load on your browser? Could someone explain? So let's say this is your laptop. Again, not very deep. Whatever you know, whatever you understand, whatever you heard, that's enough. Okay. So you open a browser like Chrome and you type in google.com, happens towards anyone.
Yeah, it will send a request to the server, and from server it will get that page, and then in the
Okay.
UI we can see that.
So you're saying that it will send a request to a server.
Yeah,
mm, UI is nothing but your browser again, right?
yeah.
Okay, it will send a request to the server. The server will send a response back, send a request, and the server will send you a response back. Okay, right? But how does your computer know which server?
IP address.
IP address. So how does the browser know your IP address? IP address of google.com, for instance.
Mm. I think DNS.
DNS. Okay, IP address. So remember this. So
I'm
IP
not sure
address is
whether
a
I'm saying correctly or
no, no. Don't worry, that's fine.
not.
So IP address is the way computers locate each other. Okay, so that's a correct answer. So what is this new thing called as DNS, right? DNS stands for anyone?
Domain name.
Domain name server.
Domain name space.
So it's domain name service. Okay,
Sir,
so a server which runs domain name service is domain name server. That's obvious, but it's called as domain name service. So what does a domain name service does is it converts your domain names in the sense, google.com is a domain name, netflix.com is a domain name, whatsapp.com is a domain name. All of these are domain names. The domain name service helps in converting the domain names into IP addresses. So remember, computers only understand binary, and IP address is not binary, but it will be converted into binary by your systems. Okay, so this DNS also is not a simple process. It's not like there is a magical thing called as DNS and you get an IP address. So just imagine, right? I mean, talk about the journey of your browser, right? So when you type in google.com, in Chrome is the application you're accessing. So Chrome checks its cache. What's cache? Cache is something that is stored inside the memory, right? Cache is cache is the information that your system might need to access very frequently. So it's spelled as CACHE. Some people pronounce it as cache. Some people call it as cache. Okay, so not the cache, but not the cache. It's so this cache is something which stores frequently accessed data readily available for the system. Okay, so your browser might have the IP address in its cache. Okay, if it doesn't have, what is the next hop? Where does your browser send the request to? It sends the request to, I mean, forget about the server, but how does your, let's say you, even if your browser knows the IP address, how does your browser communicate with with the particular server which has that IP address? What is the next hop in your from your computer? Let's say in your home network, what would be the
router,
next hop?
router.
Your router, right? So the next hop would be your router. Okay, so most of the routers have the caching mechanism. So let's say someone else from your home also accessed google.com very recently, okay, on a browser or a mobile device or whatever it is. So earlier, the router was the one which provided the IP address. So now though this person is someone else and this is someone else, but or same person from different devices, but now your browser can get the IP address from the router cache. Router stores the IP addresses along with the DNS names in the form of key value pairs like this, you know, domain name followed by IP address. So your router will provide immediately here. But let's say no one else has accessed google.com so far in your home, new router, new IP connection, everything. So the next request, where does it go? Next request.
Maybe next IP address.
Subnet.
What is, sorry, what is that?
Internet
Internet
network.
service provider. Yeah, internet, but who? Internet service provider. For example, if you're taking your connection from um, Airtel, it will go to Airtel regional office or wherever they maintain their hub. If you're taking it from Tata to Tata, if you're taking from Verizon, it goes the next stop goes to the Verizon. If it's AT&T, it goes to AT&T. Okay, the ISP maintains something known as you know a DNS resolver, because for an ISP, hundreds of users or thousands of users connect to this DNS resolver. So this might have the required IP address for you, and this might send the answer back to your router saying that, hey, this is the IP address for google.com. So then the router itself caches it in its memory and also sends it to browser, and browser also caches it. So in that case, if someone else accesses from another device, again, it did not go all through this way. It can get it from here. Okay. So where does this ISP get, this DNS resolver might get the IP address? Maybe someone else who is using the same connection might have already accessed google.com some time ago. Okay. So, but let's say no one else has accessed google.com. Okay. From this ISP, from this internet service provider. Okay. Internet service provider, as the word says, someone who provides internet. Like in India, it could be Airtel, Act, you know, uh, who else we have? Yeah, it could be, if it's a mobile device operator, it could be their DNS resolver also. Okay, so suppose even this DNS resolver also doesn't have the IP address stored. So where do it go? Okay, so in our domain names we don't see, it's hidden, but there is a dot at the end that signifies the root server of DNS. Okay, that signifies the root server of DNS. So for all the, see, we have so many top level domains, or what we call as TLDs. Top level domains are nothing but, when you buy a website, your website name could be one of these things, right? Like whatever your website name, .com, .org, .edu, .tech. These days we have all kind of extension, all kind of top level domains. .tech, dot, uh, .me, .website, .blog, .tv,
.in.
you name it. .in, .co, .co.in was also in existence for some time. .com.au, .co.uk, .gov for the US government websites, okay, .gov.in for Indian government websites, and so on and so forth, right? The list is almost endless. There are very high level, top level domains, okay? So these are all called as top level domains. And at the top of all these things, we have something called as root server, which is denoted by dot. Okay, so your ISP DNS resolver will send the request forward to a root server. Okay, root server is the one which has the list of all the domain names, sorry, top level domains. So it reads your IP domain name and it says, ha, okay, you're asking for my google.com. So I need to send you to the DNS server of the .com TLD. Okay, so it sends my request to .com .com servers. Okay, now .com servers maintains the list of all the domain names under .com, like Google, Facebook, whatever is there. So now this request is further forwarded to the place where this domain name is bought from. Remember, when you can I register a website called as google.com? Because I have my AWS account today and I have the option to create some servers and load balancers and many other things. Is it possible for me to run a website called as google.com?
No, it's already
It's already done. So how can I you know know that it's already done, right? Or who issues them? Okay, so there are these people called as registrars. Okay, so for example, GoDaddy, you might have heard about GoDaddy, right? GoDaddy is one of the registrar. Amazon has its own registrar. You have Namecheap. Okay. What else? You have something called as Freenom. Lot of other, you know, registrars, DNS registrars, we call them. Okay. What they do is they maintain the list of all the IP addresses and, sorry, domain names, and they sell them for a particular price. Okay. So if you're going to buy a website, for example, you have to go to something like namecheap.com or GoDaddy. Don't use GoDaddy, it's bad in my experience if you ever want to use it. Okay, so for example, if you go to something like Namecheap, you can search for a domain name. Let's say I want to start a domain name called as Telugulo Devops, for instance. Okay, hoping no one has already started the website. Okay, so it gives me a code. It says, okay, if you want to get this website, you have to pay $9 per year and start using it. Or if you want alternatives like telugudevops.org, it's available for 7.5 almost. If you want something for telugudevops.ai, it costs me $70. Who wants to use .ai? Everyone is going to anyway forget. Or if you want to use .inc incorporation, it's almost 1 grand. Who wants to use this? Anyway, so these are the various prices. For example, if you want to go for telugudevops.biz, for instance, it costs you about $5. Okay, so you can buy from one of these registrar, and this will be registered for you. Okay, you might not start a website with this. Just because you have a domain name, that doesn't mean you have a website. Domain name means just you have the name. You have to use it to configure your application to point to this website. That we'll talk about later. Okay, or something like GoDaddy, you do the same thing. Okay, so Google might have also bought from someplace. Actually, Google has its own registrar now. So it goes to the Google registrar, or maybe let's say it's a third party registrar like Namecheap. So Namecheap says, okay, I know google.com was bought from me, okay, but they maintain their DNS records in their own servers. So I can forward them your request to something called as name servers. Okay. So Google has a list of servers which are called as DNS servers, or name servers, where they maintain all the list of their internal domain names, because they have a lot of subdomains and main domains, right? Like you have drive.google.com, you have you know playstore.google.com, all kind of domain names, right? See, this domain name resolution even works for your apps also. So when you install an app, obviously it might not show up that there is a website name or domain name, but in the back end there's a domain name also, which your browser is going to handle, which will not show you. See, all your mobile apps are nothing but customized browsers which can show only one application. That's it, nothing more. Okay, drive.google.com, or youtube.com, all these things are maintained by Google, right? So they maintain these entries in their DNS servers. So before your server gets the DNS name, this these all steps do happen. Okay, but there is caching at every layer. Now, once google.com sends the information from their name servers, okay, we call them as name servers, your registrar caches that. That means if anyone else is accessing from anywhere, uh, and it comes to, I mean, whoever is registered with Namecheap, or rather anyone makes any request, it need not go to even name servers, it can retrieve from this place also. Okay, then you know .com, top level domain server, it also caches the information. Your root server caches the information. The ISP DNS resolver caches it. Your browser caches it, and your router caches it. Everyone stores it. That's why it's a very distributed system. So next time someone from your home tries to access it, they don't have to do all these hops. It can directly get from your router. Okay, and next time if you open in another browser, same browser, it will obviously have it in the cache itself. Okay, so this is what happens before your system knows where to go, to go where and access which server. Okay, so the internet communication basically happens over IP addresses. Okay, IP addresses are like telephone numbers for your mobile telephony. Okay, um, so just like we maintain a phone book, our routers and all these things maintain a DNS name, DNS records. And also remember this what if google.com changes their IP address? Okay, an IP address is nothing but, as I told you, the way with uh, sorry, the identity of a system in the internet. Okay, it can locate it will help others to locate you with the IP address. Okay, just like a phone number. So now your system has the IP address. It will go to the required server. Okay, that's the next part. So this is how DNS resolution works. Why should we talk about all these things, right? Because this may be also an important part of troubleshooting issues when your applications don't work. Okay, how you could use this, I cannot say right now. Okay, but you have to understand this flow. And also, of course, when you create an application, when you create a DNS name, or when you create a website, you will have an IP address only. That IP address should be mapped with, for example, let's say I wanted to start this website called as telugulodevops.com. Okay, so I start this telugulodevops.com is nothing but DevOps in Telugu. Okay, so when I start this website, first I create a server, I install my application, I add my code, and do all this stuff. Okay, later I need to ensure my application or this web server uh, has to point to DevOps, telugulodevops.com or whatever, devops.com, whatever it is. Okay, so that's part also will be handled by DevOps engineers using, if it's AWS, we use a tool called as Route 53 or a service called as Route 53, which will help you to do this mapping. Okay, within Route 53 you can also buy your own domain name. Okay, just like Namecheap, you can go to Route 53 in AWS itself and buy it. We'll see that a little later, not immediately, but just giving you the idea. So why are we learning it? We may have to troubleshoot it. We may have to configure our server to point to a certain domain name. Okay. Um, so after the IP address is up, okay. Any questions till now? No questions. Okay, cool. Uh, Now let's say you get an IP address for a particular server, what we call as a server. Okay. So if it is a single server, that's fine. But remember, in IT systems, like any other systems, are not always 100% fault proof. Okay, they might be unavailable for various reasons. When I say unavailable, that means the software running this system, this server, a server is nothing but a computer, guys. A server is a computer specifically doing a certain task. Okay, so this computer might fail because of many number of reasons. There might be a software problem, there might be a hardware problem, networking problem, or whatever it is. So no matter how big a system you create, google.com attracts hundreds of users, or sorry, millions of users, right? uh, so how do you handle the huge traffic load, right? For that you would need some kind of high power system. That's fine. You might have a very high powered system, like something that is 1 terabyte, 3 terabytes of RAM, and 400 cores of CPUs and all this stuff. Okay, uh, but but it might fail anytime. So then that means it's a single point of failure. Everyone across the globe will not be able to see google.com website. Okay, because google.com website pages are coming from this particular server. Okay, so then what does Google have to do? Google have to, you know, uh, create a secondary server, which will, which we call it as a redundant server, because it has the same information, same software code, everything is same as the first one. It could be of same size or different size. When I say size, I mean the specifications, the CPU, RAM, and storage part. Okay, so you are creating redundancy. Redundancy means a kind of high availability. But remember, each computer has its own unique IP address. Let's say this has something like, 89.89.20.19. This might have 21. Okay, but the problem is, you know, DNS name can point to only one server. So which server would you send the data? So either you can have it in active passive, or meaning always the request goes to this server only. This server is only on standby. Whenever this server fails, then you have to manually redirect the traffic to this particular server. When I say redirect, what do you need to do is, update the DNS record in such a way that all the requests coming earlier something might be like this. Okay, google.com, in your DNS it might show. Okay, like this you might have updated in your DNS servers. So now that means all the requests are still going to only one server. When, let's say, there is a failure and you have some monitoring system which will tell you that this system is not working right now, then you have to come here and manually change the DNS name to point it to the secondary server. Okay, but this is not a good practice, because this, whenever humans are you know involved in doing something, it takes some time for them to think and log in and do all that stuff. So it is called as active passive setup. Some companies might be using in for some of their internal applications, but not a recommended solution. To have truly highly available application, highly available in the sense which never goes down, or goes down very rarely, only for a few minutes in a month or something like that. So for this, what you need to have is something like a load distributing system. Okay, meaning it will receive the request from end users and distributes the load between these two servers. So that kind of systems are known as load balancer. Okay, as the name says, a load balancer is something that that distributes the load across different computing nodes. Okay, or different computers in simple terms. So this one will act as a uh, you know load distribution. There are several algorithms, load balancer algorithms, something like what do you call? First one is, simplest one is round robin. A round robin is something where um, it sends all the first requests to this one, second request to this one, third to this, fourth to this, five, like this, in an order, round robin, as the name says, right? And there are some other algorithms, like least connections. So if you're using a banking application, right? When you first connect to a banking web application, you give the authentication details like your username, password, and everything, right? So that has to be cached in here. So next time if you go to this server, it's not going to work, because it's going to again ask you. Let's say you logged into HDFC net banking website, and after giving the credentials, you clicked on your credit card section. If when you clicked on the credit card section, if the browser sends the secondary request to this one, okay, then it doesn't have your authentication details, so it will again log you out and ask for the authentication details. So in case of such applications, all the requests have to be sent to the same server throughout the session. Throughout the session means from the time you open that browser, that application, till you log out. Okay, in that case, more than round robin, there are other systems which could be effectively working, something called as least connections, meaning which server has less number of users connected right now at this moment. Okay, that's a least. So those are the rules, that are followed by your um, system. So your load balancer is also like a computer, but it's more like a router. Okay, so it also has its own IP address, maybe something like 89.89.20.22. So now, instead of updating either of these IP addresses in your DNS, you update this IP address. Okay. So instead of updating either of these IP addresses, you update the .22 IP address. So your request comes to your load balancer, and your load balancer will direct your load to either of these servers. And also, load balancers have this, many of the modern load balancers, at least the load balancers on the cloud, have this capability of, recognizing if the service is working on a particular server or not. Meaning, if it is able to send the response back to the user or not, the load balancer can detect. Let's say, at a given point in time, this server has stopped working, or the software has stopped working. So now the load balancer will automatically stop sending requests to this server and keeps on sending servers to requests to this server. In the meanwhile, you can have a monitoring and alerting system which alerts your operations team, and the operations team comes and fixes this issue. Okay. In the meanwhile, from the end user perspective, they will not see that this server is even down, because all the requests are actively being served by this server. Okay. So that's why sometimes two might not be enough. You might have more than two. Okay. This is Okay, right. So and an application has various layers. For example, when you open google.com, it gives you the web interface or the UI, basically UI. But when you type in some request like, let's say, IT architecture, you type in. So it gives you something from your cache. So there is some element executed here. Okay. And when you hit enter, it will have to process this information and give you some output. And what you see on your Google search might not be the same as what I see on my Google search. Why is that? Hello? Hey, if you're not speaking or if you do not have a question, please mute. Um, so the question is, my Google search is different from your Google search, right? The very reason because Google stores all our information about our browsing history, our purchase history, and our user behavior basically. And based on that, it gives us some output. So if I type in architecture, I might get different set of applications like Gartner and some YouTube recommendations and all. You might get different set of results based on what your browsing history was, what your you know what are your preferred websites and all that. Based on that, Google maintains this list. So that means there is some business logic that is processing in the back end, right? So then to present the web pages in the form of these pages, which we call as HTML pages, you need something like a web server. But to do the business algorithms, to do the calculation that I just talked about, you need another software running. See, a server is nothing but a computer running a specific version of software. For example, you might have heard about the servers like web server, application server, or database server, okay, or simply database. So if you take a computer and install a software like, let's say, Apache, which or HTTPD, these are not new terms, names of the softwares. Okay, so Apache or HTTPD, what happens? It becomes a web server. It will let you serve web pages to the end user. If you install something like a WebSphere or a Tomcat application, these are application servers which can run Java application. Okay, these could act as a front-end applications as well, but they can do the computation also. Or if you take a computer or a physical machine or a virtual machine and install MySQL, it becomes a database server. Okay, so there is nothing like a database server. You take a particular computer on which already has some OS installed, obviously, right? So it might have some Linux operating system like Debian, and on top of it you install MySQL, or it might have a Windows operating system. On top of it you might install something like PHP. It becomes an application server. Okay. If you want, you can install all these things on the same server. You can install Apache, WebSphere, Debian, Windows, all on the same system, and all can function very well. No problem. But generally, the principles of IT architecture recommend that you have to run only one particular software. When I say software, the crucial one, of course, every server runs a lot of other softwares that are required to operate your system. For example, the network managers, um, the power managers, a lot of other services are also running inside the servers, which are essential for the system. But from the end user perspective, if you're creating a server, it has to run only one particular application, such as a web server software or a PHP software or a MySQL software. You cannot club all of them into single in a single server. The reason being that will lead to conflicts. Like, let's say there is a issue with MySQL server which is consuming a lot of data, which is consuming a lot of RAM. Then your PHP doesn't have any RAM to use. Okay, so is the case with your web server. So what you do is, for the presentation layer or the for the web layer, you create one set of servers. For the application or the business logic, for example, in google.com, I told you, right? um, you need when you search for a particular term and hit enter, it returns results based on some computation. What is the computation? Where are you located? What is your previous search history? What is your previous browsing? Let's say, what are your preferred websites, right? Google gets this information from various sources, including your operating system, including your browsers, uh, also third-party websites. They gather information from everywhere, and based on your user behavior, they are going to suggest you results. So to process that, it needs another set of servers, which we call typically as a app business logic servers or app servers. Okay. So you need another set of servers to run those kind of operations. Now, Google also has to store all the data about the users and the various web pages and all these things. That those are typically stored in your databases. Okay. Then you have another set of servers which we call as database servers. Okay. So this is what we call as a typical three-tier architecture. Okay. Sometimes the app and web layer might be working in the same one. Okay. Sometimes this could be separated. Okay. So you have your web layer, your application layer, your database layer. Okay. This kind of setup is known as your three-tier architecture. Okay. Uh, and also remember another thing. These are right now we have drawn physical machines, but before even the cloud came into picture, there was another concept that became a big hit in the market, which was called as virtualization. Just like how everyone is talking about DevOps and SRE and cloud these days. When I was a student, you know, very young, people were talking about VMware, VMware, VMware. Okay, everyone was saying, "Oh, learn new." I mean, Java was already the big hit by the time. Java, everyone who wanted to get into development software, they had to learn Java. Okay. Afterwards, then people stopped talking. I mean, Java was still on the rage, but the other thing people started talking about was VMware, because VMware is the company which made this virtualization a big hit. Okay, virtualization is there even before that, but they have made it into mass market. Okay, so what this VMware does is, or what VMware products do is, let's say you have a physical machine, okay, which has some capacity. Let's say it has a capacity of 1 terabyte and 64 CPUs cores. Okay, just giving an example. So this one now, generally, when you start the computer, which program? I mean, where does the control go to? When you switch on a computer or a laptop, what happens? Okay, your
Windows.
computer goes through these Windows. No, no, not directly Windows. Windows is your operating system, but before that, what
Yeah.
happens? Sorry,
Reload by
BIOS. Okay, before BIOS, there is something called as post power on self test. Then it sends to BIOS, or these days we have UEFI, Unified Extensible Firmware Interface. Again, you don't have to remember all these things. These are at a very basic level, very deep level. So UEFI means Unified Extensible Firmware Interface. Okay, so this basically is nothing but, as the name says, basic input output system. This is going to check if your all the components on the system are available, like hard drive is available, memory is available, fan is available, CPU is available. It checks all those things, and next it passes the control to, if it detects a hard drive, and if the hard drive has what we call as a master boot record, MBR. So when you install an operating system, it creates MBR on your hard drive. So it means, it's like saying that, hey, it will communicate with BIOS, will communicate with master boot record and pass the control from BIOS to MBR. But all these things happen in a split second, so you don't see this in the modern systems. Okay, or UEFI passes the thing to your MBR, and MBR sees what operating system is loaded in the system. It need not be Windows always, guys, folks, right? It could be a MacBook, it could be a Linux machine like mine. Mine is a Linux machine. Okay, don't think Windows is the only operating system. So it passes the command to your operating system. Okay, then your operating system and whatever applications you open, your operating system help you work with them, like a Chrome browser or a notepad or a Word document or a VLC player or whatever it is. Okay, uh, your operating system helps you to do that. Of course, these days everything is centered around the browser with a lot of OTT apps and all the other things. But yeah, so when you get a physical server, also it also has its own BIOS or UEFI. Okay, just like your regular laptop or computer. On top of it, you generally, what you do when you have a laptop, you install your operating system. Have you ever installed any operating system on a laptop or a desktop? No?
Yeah. Yes.
Okay. You installed. Okay. What operating system did you install?
Windows.
So
Windows
what do you need to
servers.
do? So what do you need to do to install the server?
We need an accurate hard disk. There we need some. So to read our operating system, we should be having some DVD or something else to any pen drive or somewhere.
Mm,
We can copy that into the hard disk, and
mm.
then we will install that, because the operating system itself is a software that we can run that as an administrator somewhere. So it will
Yeah.
check all these versions.
Yeah. So you need to have something called as an ISO image to boot load your operating system. Okay. So you have an ISO image on a pen drive or a DVD or a CD, and you insert it into the particular machine. Um, you know, and it will boot from that. It has to be a bootable image. It should also have a master boot record. It boots from that operating system image, and you install the operating system. Okay, it could be any operating system, not just Windows. It could be Linux, FreeBSD, anything. So, but that means on one operating system, if you install, let's say directly, um, let's say you install a Debian operating. Debian is a Linux, one of the Linux operating systems. So if you install Debian operating system, um, so what your computing best practices says is, no matter how big a system you have, how good system it is, it should be running only one end user application. Like it should run only one Apache application, one Tomcat application, right? I mean, one instance of a web server or a one instance of a application server or a DB server, but it might not be fully utilized. Okay, so if you have to create another system for another set of services, you have to use another set of servers. Okay, and always remember, you have to take into factor the high availability. One system will not work for all the for a particular service. There should be redundancy, more than one system doing the same thing, because if one system fails, you have other systems to send your traffic to. Okay, so that means if you use physical machines for a lot of these services, it becomes very cumbersome, very huge to manage. So that's why there's this concept that came into picture, which is called as virtualization. So virtualization means you install a software like an operating system, but very lightweight one, which is called as a hypervisor. What this hypervisor helps you do is, this hypervisor lets you divide your physical machine capabilities into smaller machines, which are called as virtual machines. So this could be a virtual machine which is running Debian with, let's say, 64 GB and 8 cores of CPU. There could be another VM which could be running Red Hat Linux, okay, Red Hat Enterprise Linux, or what we call as RHEL, with maybe different capability. This could be running with, maybe this is for your database servers, you need high memory, so maybe something like 128 GB, 8 cores. Maybe then you can create another VM which might be running, let's say something like Windows operating system, Windows server with, let's say, 32 GB and 4 cores of CPU. Okay, maybe again memory intensive application, or you could use another one to just install Windows Server. Maybe this is running Windows Server 2019. This is running maybe Windows Server 2022. That I know the specs don't match up, but I'm just giving an example. Okay, so like this, you can create any number of machines, but the total capacity should be matching this one. Meaning, if you have 1 TB, you cannot create 100 machines, each of them with 64 GB, right? Because it has to be divided. The available RAM and CPUs should be distributed across all the virtual machines. So your hypervisor is the tool which lets you to create multiple virtual machines on the same physical machine. Okay, the reason it is called as a virtual machine is because it's actually using the resources of an underlying physical machine, okay, which we call as a host machine, and this is the guest operating system which runs its own operating system Okay, and it's independent from the other VM which are running on the same physical machine. So this can be rebooted independently, this can be updated independently, this can be deleted independently without affecting other virtual machines running on this server. Okay, so it solves that problem of only one service has to run on your physical machine. So maybe this one is running only your web server. Okay, maybe this is running your MySQL. Maybe this is running something else. Maybe some caching service. Maybe this is running some NoSQL database. So how do you achieve? Now you have division of your VMs, but how do you achieve the uh, high availability? So it's better recommended to use a similar physical server like this and do maybe same physical partitioning or same virtual machines and create a redundancy. So you're solving the problem of redundancy also with this one. But earlier, to run four different set of systems and at least two each of them, okay, let's say you have to run four different set of services. One is for your caching, one is for your web service, one is for your database service, and another one is for your business logic. So you needed at least each of them four servers, four physical servers, and a redundant server for each of them. So you need 8 physical servers. Now, with 2 physical servers, we are able to achieve all these things. Okay, so that's why virtualization is such a big hit. And if you ask me, virtualization is actually the precursor for your cloud. If virtualization was not so popular, we would not all have these jobs, because it made the IT services more affordable. And with single physical machine, you can run multiple services and multiple VMs. uh, so with that, the cloud was also made easy. So today, when we create a server on cloud on AWS or Azure, it is nothing but a virtual machine, uh, which is again the but this time when we are creating on cloud, it is dynamically created for us by the hypervisor, which will again receive a request from another software. Okay, so in earlier days, people used to connect to these machines using their different monitors and install hypervisor inside this one. And after installing hypervisors, they used to take various images, like someone has spoken about, so like a ISO image of Debian, ISO image of RHEL, ISO image of Windows Server 2019, so on and so forth, and install all these operating systems one after the other. Okay, now it's mostly automated. Okay, so this is what virtualization means. The reason I'm covering this is you need to understand the difference between physical machine and a virtual machine. We often hear this term called as virtual machine. All right, very often we hear this term called as virtual machine and a physical server. Physical server is something like a real computer which has CPU, RAM, and all that stuff, whereas virtual machine is a unit, or a part of your physical machine, which is independent and which has its own full-blown operating system and all that stuff. Okay, so any questions before we wind up for today? Okay, so today's task for you is read about these things. Okay, what is a three-tier architecture? What is n-tier architecture? What is microservices? Okay, so tomorrow we're going to continue with some networking concepts. We'll explain. Um, I'll explain the concepts of IP addresses. How do you identify which is what IP address, and what are the classes of IP addresses? Yeah, it's going to be mathematically extensive class. Okay, any questions? All right, then, if you do not have any questions, have a good day or good evening based on wherever you are, and talk to you all tomorrow. Thank you.
Happy Easter forever.
Thank you.
Thank you.
Sir, when is hello?
Thank you, Kiran.
Thanks, Kiran.
When is the next class tomorrow? Timings. Hello? Hello? Need the next class timing, sir.
Yeah, I can hear you. Please tell me.
When is the next class timing?
Same 6 to 7 tomorrow morning, IST time.
Okay, thank you, sir.
Okay, thank you.
Hello.